Welcome to other video of JVM architecture video series. So last time we discussed just high level overview, but today what we are going to do. In my last video, I have discussed about what is virtual machine. We discussed various types of virtual machine, and also we discussed what is application based, otherwise process based virtual machine is. So there we end our discussion by giving a brief introduction to Java Virtual Machine. So as I promised, today I'm going to open up this Java Virtual Machine and dig into that what is inside. This will be a series of videos, and this will be a start of that, just open up the JVM and see inside. So in later videos we are going to take one by one component and discuss more in detail. If you have not watched my previous video, I think it's better to watch that video because that is the very beginning point for this series. And also, if you already watched, let's do a certain recap. So there we discussed, we have two types of virtual machines, and JVM is falling under process-based, otherwise application-based virtual machines. So we discussed there is nothing exists called JVM. It's a totally completely virtual. So when you install JRE, it will deploy the particular code which is required to create JVM for your particular platform. If it is a Windows, it's different. If it is a Mac, it would be different. So what it does is it will deploy the particular code. So you have a JDK, you have a JRE, but there is nothing really exists called JVM. In other words, if you are not executing any program on your computer in that particular time frame, you don't have a JVM instance on your computer, only JDK and JRE. So when the moment you start a Java program, then it will create JVM instance on your computer, and the moment your program exit, then JVM instance also will die. So JVM instance will only exist on your computer until you run your program. So if you're executing 3 different program or 4 different program on your computer on the same time, then there will have 3 different JVM instances on your computer. That's how it works. So let's say after 5 seconds, one program ends, then only you have n-1. Otherwise, if it was a 4, now there is 3 different JVM instances. When all programs exits, then no JVM instance exists on your computer. So why I explain that? Because a lot of developers has a mind that JVM is a static constant thing on your computer. JVM exists and all your programs is sharing same JVM. There is nothing like that. Okay. So then how it knows to create a JVM instance? Okay, how you compile your code? Let's say you have a hello world application. So you just type java c hello world.java. Then it will create Java class file, hello world.class file. So now how you execute this? If it is a command prompt, you just type java space hello world and press enter. So when the moment you give the Java in your terminal keyword and a space your file name, the Java means you tell your operating system, hey, give me a JVM instance for me. Give a JVM instance for me. So Java hello world. So you ask operating system, give a Java JVM instance. So in a JVM instance, when it create a non-daemon thread. Okay, we are going to have a in detail discussion about a thread, but for a moment just keep in mind you have a daemon threads and non-daemon threads. So when JVM starts, it's create a non-daemon thread, and your class must have a method called public static void main. It must be void and it must be public. So let's discuss why it is in a different video, but for the moment keep in mind public static void main. So when your JVM instance create, what it does is it take this method to execute. So from there onwards you can drive your program through this method. So now we have a daemon thread. So this daemon thread is capable to create the other non-daemon threads. So what happened? There is a two ways this program get exit. Otherwise, this JVM get destroyed. One, if no non-daemon threads are exit, that means all the non-daemon threads which you created are closed, destroyed. So then your JVM instance get die. Or else otherwise, application can do suicide. So that means it can call exit method, system exit method. Then also the JVM instance will die and exit. So now we have a background idea who this guy is. That means our JVM exists while your application running. In other words, JVM exists while at least one non-daemon thread is exist. If there are no non-daemon thread exists, then JVM die. So that is the life cycle of JVM. JVM has like exact purpose of living. JVM born when your application run, JVM dies when your application ends. Okay, so now if you open up JVM, you go to JVM and you open up what are inside. Okay, before I explain that story, just take a very high level picture into JVM. Just assume JVM is a box. Keep in mind it is not exist, but for the sake of understanding, just assume it is a box. So you open the box. Now you can see three components. What are those? Okay, it's like this. Forget about JVM. Forget about all technical words. Just focus something. Okay, so you need to throw some balls to some target. Okay, you have 1,000 balls. You get 100 balls per time, and you need to throw those balls. Okay, so now we have three stages. You have a storage, which is a big storage with the balls. So you need to take those balls and take into your place. Okay, there's a second stage. Now third stage, you need to take this ball and throw. So now, okay, what are the activities we need to perform? Okay, so we have to go and take the balls into my location, my place. So we are loading balls from my storage to my basket. We are loading. Okay, so then balls can't stay on the ground just right. You have to have a container like a basket, otherwise it will go all over the places. So we load and we store. We store in my basket. Loading, storing. Now my objective is, my target is throwing these balls. So now I need to take them, throw. Loading, storing and execution. Okay, loading, storing and execution. So this is the three tasks if you want to throw the balls. So now we are going to talk about JVM. So you have Java files, .java files, and you converted those into class file. Now class files are there. Now what you're supposed to do? You need to load this class file into your JVM. Loading, which is other words class loader. Okay, so you load your class, which is called class loader. So now the loaded class should be stored, which is a memory area. The storing place is a memory area. Class loader, memory area. Now you have objects instruction on your memory. Someone has to be there to execute, which is called execution engine. Loader, storing, execution. Class loader, memory area, execution engine. Those are the three components inside your JVM. So now let's dig one by one what inside those particular area. Okay, if you get high level picture for JVM, okay, so you have JDK. Okay, so you have a JDK and you have a JRE. And inside that you have a JVM. So now you should understand JVM is inside the JRE, JRE is inside the JDK. So JDK there are other tools and components than JRA, for example Java C and JRA. There are a lot of libraries other than the JVM. Okay, so this is how very high level where the JVM is. So now if we go and discuss about what is inside the JVM, and before that we discuss what it does is it is load and it's store and it's execute. Okay, so load is class loader and store is memory area and execute is execution engine. Okay, so now if we take this memory area, okay, I'm going to discuss this class load and execution engine in different videos because it's like there are a lot of things to discuss. So this memory area is divided into few sub areas. Okay, so let's discuss this one by one. One is method area. Okay, so one is method area. Then second one is heap area. You may heard this in many times, heap area. And there are other thing called stack. Okay, so almost not almost, lot of developers think in a memory you have a heap and stack. That's what the common answer they gave when asked questions, but not only those. So and after stack you have PC registers, and finally you have something called, forgive me, I'm not good on drawings, there's something called native method area. Okay, so we have 1 2 3 4 5 different areas on this memory area. Okay, so memory area can be divided into 5 categories. So when you load the class, right, so it will load all the class information into this method area. Okay, so this is there for keep the class information, some type information about the class. And you have a heap area. Okay, when you load this class, all the objects will comes here, instance objects, and all the objects data will comes here. Okay, instance or object. So for each and every JVM you only have one method area and one heap area. Okay, stack and PC registers is different. Stack will keep the method information, or otherwise like local variables, those type of things. Like for example, in when you create your thread, it's go to a method and it will create a one frame in this stack. So this is create per thread. Okay, this is create per thread. So you have a stack and you have a PC register. The stack, what it will do is when you go into the method, right, so let's just assume this is a stack. So you go to method 1, right, so it will create one in a stack, right. So if you go to other method, it will create other frame. You know the how stack works, right? So it will create other frame, right? Likewise, it will create a frame per thread, or per it's a thread base. You have one stack per thread. It will create a frame whenever it's going to the inside a method. So when it will put, but whenever it's exit from the method, it will pop this frame out. Okay, it will pop this frame out. So but if the PC register, what it does is, if it is not native method, if you are executing your own method, but if it is not a native method, PC register will hold the information about next execution. Okay, so this will hold information about next execution. Okay, it will hold the information about next execution, right? So native methods we can discuss a little later. So what it does is, it will if you're loading, if you're accessing any native method from your program, so those this area will provide facility to hold that native method and method information and stuff. So go back again, method area, what it does is, it will load the class information, types information, and heap area, it will create object of object, it will hold the object information. So this is one per JVM, but stack and PC registers, those will create per thread. It will create per thread, right? It will per thread basis, and a stack, it's holding your method information, local variables, and those. So that's why, like that is the reason, if you, let's say you have a method A and method B, okay, so if you have a variable int x here, you can't access int x from here. The reason, when you invoke this method A, it will create a new frame for method A. Okay, so but when you exit from the method A, this will destroy, this frame will take out from the stack. So information about the x variable is holding by this frame. So when it taken out this frame, there is no place to hold this x information, and in other words, x information has been destroyed. So that is the reason you can't access this x information from here. But if you call this method, if you create this method, if you are going to create this variable outside this, before this thread exit, then you can access that. Okay, so just to get a quick recap for before next step, if we take method memory area, okay, so size of the memory area depends on each virtual machine implementation, because certain virtual machines used very large memory areas, and certain virtual machines use very limited memory areas. So it will split to the method area, heap, stack, and PC register, also native method area. So these two is per virtual machine, per VM, 1 per VM. It's 1 per VM, but these are private per thread, otherwise per thread. Okay, it will create per thread. So now this is the very high level. Now we are going to take these three out and see how this work, because this is per thread. So let's take these two out. Okay, just assume a scenario which you run 4 different threads. So if you take stack, so you have 4 different threads. This is a T1, T2, T3, and T4. Okay, so this thread may invoke 3 methods. Okay, M1, M2, M3. So we discuss this will it will create a frame per method, right? So this may have a 2, M1, and M2. This may on M1 only still, and this may M1, M2. But this fourth thread is little different. From this M2 native method area, so it will access some native method from M2. Okay, so this is just a okay, if you don't understand this, just assume a scenario. You have a method A, okay, from that you call method B, okay, from that you call method B, and just think, if you get the implementation of the method B, from there you call method C. Okay, so you call method C. Now when you enter the thread into your method A, it will create a first frame, and from there you will go to method B, it will create a second frame, and it will from B it will call to method C, it will create a third frame. But from here what it does is, it will from the method 2 it will access the native method. Okay, so now this you know, right, this when M3 when C method is exit, so it will destroy this frame, and when B method exit it will destroy this frame. When A method is exit, it will destroy this frame. Right, so now if you consider the PC register, right, so we discussed PC register is there to hold the information about Java methods, right? So there may be a 4 different location for information: T1, T2, T3 and T4. Okay, so now what I want to explain you is, now you can see here, so this T4 thread is accessing native methods, but our PC registry is supposed to hold information about the Java method but not the native methods. So what happens is, if you consider this given movement, this exact given time frame, there will be nothing inside this, maybe it's null or undefined, if you consider T4. Why? T4 right now is accessing T4 thread right now accessing this native method, therefore nothing would available on behalf of the T4 inside your PC register, but it will hold the information about all other 4 threads. So that is how if you dig into one more step regarding those memory areas, how it will work. So this is a stack. Okay, so this is native methods and this is PC register. These will create per thread. Okay, per thread. Okay, in this video we have taken very high level view about JVM. Okay, we just open up the JVM and looked inside that, and we discussed about memory area, but we did not discuss about execution engine or either class loader, because those are little big topics which you it takes some different exact video. So unfortunately, if we upload very big video into the YouTube, like it will very difficult you to go through those. So that's why I'm uploading video topic by topic and per section by section. So now let's meet in a different video to discuss about very in detail about one unit in JVM. Till that, goodbye.